Hello, hi everyone, welcome back to the channel. So this is Ramandeep Singh. I'm back with yet another lead code problem. So I was traveling, that's why I couldn't upload a video on the YouTube. So today in this video lecture I will be solving this problem, house robber, and this is one of the problems from the blind 75 list. So in this problem we have a professional robber who is planning to rob houses along a street where each house has a certain amount of money stashed in it. What we have to do is, what the robber does is, he has like, there is a certain constraint for robbing the houses, that the robber cannot rob the adjacent houses. Like, let's take an example. Let's say we have these 5 houses, and the number in and each number represents the money which each house has. So here we have a money of 2 units, here we have a money of 7 units, here we have the money of 9 units, here we have the money of 3 units, and here we have the money of 1 unit. So our robber may start from the very first house. If he robs the first house, he cannot rob the second house. He'll have to rob the third house. Then he'll have to rob the fifth house, giving me a total amount of 10 plus 2, that is 12. Then let's take the second option. So we have the second house. If he wants to rob the second house, then he will have to rob the fourth house. He cannot rob the third house and the fifth house, hence giving me a total of 7 plus 3, that is a 10 units of money, where the maximum of these two is going to give me 12, right? And this is my answer. So what we have to do is, we want to find this answer given our array, right? So how we can do that? Let's see. So to solve this problem, what we can do is, we can first we have to understand that at any point on which we are standing, let's say we are standing on house number 1. So basically we are given this array. So this is basically an array. Each element in the array is the money which that particular house has. So we have 0 based indexing like this, 0, 1, 2, 3, 4, and what we have to do is, we want to find the maximum amount of money which you can rob tonight without altering the police, right? Without alerting the police. So if we rob 2 adjacent houses, then the police will be alerted, right? So let's see how we can do that. So first what we have to do is, let's, at any point on which we are standing, let's say point number 1 here, we have 2 options. The first one is, either take this money or move to the next house, or move to the next house. So if I rob this house, then the money that I have will be 2 units. If I do not rob this house, then I'll have to rob the next house. If I do not rob this house, then that means I robbed this house. So basically at any point I have 2 options. That's what the information which we are given in the problem statement. So let's build the solution for this particular test case. So what we can do is, let's start from the very first house. So let's say I rob this house. So if I rob this house, then that means I cannot rob the second house. So the money which I will have will be 2, right? This is the first option, and plus the money which I can obtain from the rest of the houses, right, which I want to know. Let's take the second option. If I do not rob this house, so if I do not rob this house, then the second option is, rob the second house, this one, and the money that I will have will be 7, right? So rob this house while leaving the first house. So if I leave the first house, then that means I will have to rob the second house, right? Let's move to the third house. So if I'm robbing the third house, that means I must have robbed the first house, and hence the money which I collect from the third house has to be put here. Let's rob the fourth house. So if I have robbed the third house, that means I cannot rob the fourth house. That means if I am robbing the fourth house, that means I must have robbed the second house. So put this money right here. Move to the next house here. So if I want to rob this house, means I must have robbed the third house, this one. So put this money here. So these are the two options which I am having. This is going to give me 10, this is going to give me 12, and the answer is 12. So that's the strategy to solve this problem. So let's see how we can do that. So basically what I want to do is I want to solve this problem using the strategy which I have explained here. So since I have two options at any point on which I am standing, and I have to explore both of them, and I have to take the maximum of these two, that observation gives me a hint towards a recursive solution. How? So let's imagine a function, let's call it rob. So in this rob function, or let's not call it rob, let's call it max money. So I want to collect the maximum amount of money. So in this max money function, let's say I'm standing on any ith item. So if I'm standing on any ith item, then there are two options. The first option is pick this item. So if this array is nums, and if I am picking this item, so nums of I have picked this item. If I have picked this item, then that means, what does that mean? If I have picked any particular item I, that means I have to pick from this point onwards, means from this index, from this is I minus 2. So from I minus 2 to 0. So whatever the answer I obtain from this part, I will add this ith item, this cache, onto that answer, and that is going to give me my final answer. So nums of I plus max money, and here I have to call the same function for I minus 2th item, right? So that's what I have. Then this, and I have max money. So I have chosen this item. Let's say I do not choose this item. If I do not choose this item ith, that means I do not have to add this item into this function. And in that case, what I will do is, if I am not adding this cash, if I am not adding this money into my basket, into my one of the baskets, then that means, what does that mean? That means I have to add the previous item, right? I have to add the previous item, means, so if I am not adding this ith item, means the answer that I will obtain will be from I minus 1 to 0 in this portion, right? So call this max money, and into this max money, let's call this I minus 1, and I have to take max of these two. And here let's take the base case. If I is equals to, so what will be the base case? The base case will be if I reach this point, if I reach item number 0. So if I reach item number 0, that means I have to take this item. Simple. There is no other option at this point. So I have to return nums of 0. If I reach the second item, then I have two options. What? Either I take this item, means if I am taking this item, then that means, do I have two options to explore? No, because if I am standing at index number 1, then I minus 2 is going to give me 0, means either I take this or I take this. So what does that mean? if I is 1, if I is 1, I is equals to 1, then return max of these two, max of 1 and max of item at 1 and max and item at 0. So return max of nums 0 and nums 1, right? So that is the recursive code which I have, right? What I have to do is, if I is equals to 0, return the first item. If I is equals to 1, return the max of the first and second. If it is not the case, then return nums of I plus max money I minus 2, comma max money I minus 1, max of these two things, right? So in this fashion, this is my recursive code, and let's try to code it. So if I is equals to 0, so this is the raw function. Let's create the max money function, which is going to return me my final answer. So int max money int I. So if this I is equals to 0, then return nums of 0. If I is equals to 1, return max of nums of 1, nums of 0. So here let's pass the nums, then return max of nums of I plus max money I minus 2, comma max money I minus 1. So here in this raw function, we'll have to return this max money function. From this we have to return this max money function, and here I'll have to pass nums dot size minus 1, then I'll pass the array itself, the array nums, right? So in this fashion, I will have my final answer, and let's see if it works. Okay, I am not passing the nums array here. Pass nums array, pass nums array. Okay, it got accepted. Let's try to submit it. I think it is going to give me TLE. Why? Because you can see that the constraints, you can see the constraints. The constraint is the length of the array goes up to 100. So if the length of the array goes up to 100 at any point, I have two choices, then that is going to give me 2 raised to the power n time complexity, right? That's my time complexity which I will be having, right? Which I will be having for this particular array, right? So let's see how we can solve this problem. So what we can do to solve this problem is to memorize the solution. Means what we have here is, we have a certain, so we have a certain function, let's call it max money, max m, and this is index I, and this function returns me the maximum amount of money which I can get from 0 to ith index, and from the elements starting from the element at 0 to element at I. So we have two options: either take this item nums of I plus max m I minus 2, or nums of I okay, in the second option I do not have to, just call this max m I minus 2. I minus 1, right? So these are the two options which I have, right? So let's say I call this function for I. The I is, for this test case, the I is, you can see that the I is 0 1 2 3 4. So 2 7 9 3 1 0 1 2 3 4. So max of m 4. So here what I have is nums of 4, then max m, which is 2, then max of 2 here we have, which is here at this point we'll have max of 1, right? We'll have max of 1. So this is max of 4 plus max m I minus 2, that is 4 minus 2 is going to give me 2. Then otherwise I'll have max of 3, right? I have to call for max of 3. So here what I will be doing is, this function will again call for itself for max of, so this is max of 2, then this function will again call itself, will have again two options. Take this item at nums of 2 plus max, call this max function for index number 0, otherwise call this function for index number 1. So from here nums of, so I have nums of 3, max m 3, then I'll have max m 3, include this item plus max m 2, not 2, 1, I have to move 2 items behind, then otherwise call max of m 2. So in this fashion what we have here is, we can see that we have max of m here. So this max of 2 will again be, will have again nums of 2 plus max m 0, right? And on the other hand we'll have max of 1, right? So here what we have is, we have two options. So you can see that this max of m2 is repeating, max of m2 is repeating here, it's repeating here, max of 1 is repeating, right? So what does that mean? Means once I solve this problem here, it has to be solved again here. That thing is called overlapping subproblems, right? And hence we can memorize it. Memorization means once solving a problem and storing the result of that problem in a data structure. Why? So that whenever we approach the same problem again, we can return the solution to that problem, right? So in this fashion I can get the solution to a given problem. How? Let's see that. So here in this case what I will be doing is, I will be using an array. So I will be having an array. So in this array we'll have 0, we'll have 1, we'll have 2, we'll have 3, we'll have 4, then so in this fashion we'll have it. So here at this point what I can do is, I can call this max of m4, and the solution to max of 0 is 2, so it's 2, so we store 2 here. Then the solution to max of 1 is max of these two values, 2 and 7, and that would be 7. Then what we'll have is, we have this index which is 2. So max of 2, the answer for max of 2 would be max of this one, that is nums 2 plus max m 0. We know what is max m 0. We already know the answer for this subproblem. Max of m 0, it is stored here, which is 2, plus, we take another color, 2 plus this nums of 2. What is nums of 2? 9. So 2 plus 9 is 11. That means at index number 2 we'll have 11. Then we have here max of m2. So max of m2 is solved. We have 11 for this. Then let's move here, max of m3. That is going to give me max of this one, which is nums of 3 plus max of m, which is, so here max of m is 11 versus max of 1. What is the answer of max of 1? It is 7. So 11 versus 7, the maximum of these two is 11. So that's why I stored 11 at this point. Now let's move to this sub problem, max of 3. What is the solution to this problem? The max of the left sub problem and the right sub problem. What is the left sub problem? Nums of 3, which is 3, plus max of m1, which is 7. So 7 plus 3 is going to give me 10. So we'll have 10 at this point versus what we'll have is, we'll have this max of m2. What does this max of m2 says? Max of m2 is 0, 1, 2, which is 9. So 10 and 9, max of these two is going to give me 19. So we'll have 19 at this point. So at this point we'll have 19. So at index number 3 we'll have 19. So let's move to max of 4. So here at this point, so max of 3, we already have the answer to max of 3, and at this point we can have, what we can have is, that is max of this one. So nums of 4 plus max of m2, nums of 4 is 1, 0, 1, 2, 3, 4, 1, plus what we can have is max of m2. So max of m2 is, we already have the answer to this, which is 11. So 1 plus 11 is going to give me 12. So 12 versus what else do we have? What else do we have? 12 versus, so max of 12 versus the left sub problem, the right sub problem, which is max of 3, which is 19. So 12 versus 19. So that is going to give me 19. So max of 4 is also 19. Is it 19, right? So max of 4 is 19. Yeah, it's 19, right? So max of 3 is 19. Is it 19? Nums of 3, which is 3, plus max of m1, which is 7. So 7 plus 3 is going to give me, 7 plus 3 is going to give me 10. It's not 11. I think it's 10, right? It's not 11. It's 10. It was a mistake. Then let's move to this. Okay, it's 11. Max of 3, it's nums of 3, which is, and on the other hand it's not 10, it's 11, right? Nums of 3 is 11, because nums of 3 plus max m1 is going to give me 7 plus 3, that is 10, while max m2 is going to give me 11. So it's better to take this option, which is giving me 11. So let's move to this one, fourth index. So max of m4 is going to give me, so we have max of m4, and at this point 0, 1, 2, 3, 4, this point on the left side what we have is nums of 4 plus max of m2, that is going to give me 1 plus max of m2 is 11. So nums of 4 is 11, nums of 4 is 11, while nums of 2, nums of 4 is, nums of 4, 2, 0, 1, 2, 3, 4, nums of 4 is 1, plus max m2 is, 11. So 11 plus 1 is 12. So this left sub problem is giving me 12, while the right sub problem is giving me 11. So 12 versus 11, the answer would be 12. So at this point we would have 12. So max of 4 is 12, right? So max of 4 is 12, right? Because max of 4 is maximum of the left sub problem and the right sub problem. So our answer is 12. And finally this is my answer, which is 12. And this process is called memoization. All we have to do is, whenever I calculate the result for any sub problem, for this one, I just have to store that result into this array, right? So let's first create this array. Let's call it memoize vector let's call it memo nums dot size. Let's initialize it with 0. Then here we'll be passing this memo array, and here at this point what we would be having is max money, max nums, and here we will receive this array vector of end of memo. And what we can have here is at this point we can pass this memo array. Let's pass this memo array, and let's also store this memo 0, and here let's store this memo 0. Let's store here memo 0. And we have to check if for any particular index memo of I is not equal to -1, so let's initialize it with the -1. So if it is not -1, means the result for that particular index is stored there. So in that case we'll return the answer memo of I, right? Otherwise we have to store the answer here at this point for that particular. So here we'll store it for 1, here we'll store it for 0, and let's see. Okay, let's submit it. So that got accepted. So what is the time complexity for this solution? We can see that once we solve a problem in this approach, we do not have to solve the same problem again. We just have to pick the result from this array, and hence for every index from 1 to n, I'm solving the problem exactly once, and hence the complexity, the time complexity is big of n. But here the space complexity is not constant. I'm using an array, that's why the space complexity is big of n. So this is the approach, this is the memoization approach to solve this problem. Now the exercise for you in this problem is to solve this same problem using tabulation, that is bottom up manner. So that's all for this video. If you like the video, then hit the like button and stay tuned with me, and I will see you soon in my next video. Till then, take care, bye bye.